Hello and welcome to 7.9 Notes, Factoring Special Products. So this is extending our knowledge of factoring to things that aren't exactly just trinomials and normal. Okay, these are special cases or things where you might have to think a little bit outside of the box. So we're doing some examples for you so that you know how to approach a situation, or you at least have some advice on what to do to approach a situation. So the first pattern that we have is a difference of two squares. That's when you have something squared minus something squared. And that factors very, very nicely. You don't need to go through the cross method if you can remember this method. You can still use the cross method. B would be 0. But here, if you can just remember the rule, things move a lot faster. So, if you have a squared minus b squared, the factors are a plus b, a minus b. Super, super simple. So for instance, in example 1, you have x squared minus 64. Now this rule works when you have perfect squares. X squared is a perfect square. What squared makes x squared? X. So our a would actually end up being x. Well, what squared makes 64? 8. So b equals 8. So your factors are x plus 8, x minus 8. And that's it, you're done. Makes life really, really easy. And it really is that easy. Okay, so try not to overthink it. Let's do another one that looks a little bit scarier, but isn't. Well, if you have 25b squared, 25 is a perfect square, b squared is a perfect square, they're just multiplied together. So what squared makes 25b squared? 5b. Because 5b times 5b is 25b squared. So a is 5b. The other one is actually really straightforward, right? 36. What squared makes 36? 6. So b is 6. So when you do this, you get a plus b, so 5b plus 6 times a minus b, so 5b minus 6. And that's it, you're done. That's the answer. Super, super simple again. Now, we also have something called factoring by grouping. And that's essentially what I do when I do the bottom portion of the cross method. After you set it up, you end up with 4 terms. So we group the first 2 and the last 2, we take out GCFs, and we move on, right? And that's how we get our factors. This is the same thing. The only difference is that now we don't have to do that first part. It's actually a little bit less work. And we have 4 terms already in the function. So when we group, we're going to group the first 2 and the last 2 and take out what they have in common. X cubed and 4x squared both have an x squared in it because x squared times x is x cubed. So I'm going to take out the x squared and write what's left over. Well, if I take x squared out of x cubed, I get x. If I take x squared out of 4x squared, I get 4. And that's what's on the inside. 2x plus 8 both have 2's, so I take out a positive 2, and we get x plus 4 on the inside. Do the insides match? Yes, that's one of my factors then. What's my other factor? The outside, right? Just like last time. They just look a little bit different. That's all. Let's look at example 4. Now, if you look at example 4, x squared plus 4y don't look like they have anything in common. And 2x plus 2xy, that has something in common. But I'm going to go ahead and I'm going to use some intuition, right, which you might not have yet, but that's okay, you'll get it, and rearrange some things. Okay, I'm actually going to write it in a different order, and I know this example is a little weird. They're not all going to look like this. In fact, most of them probably won't, but just to give you some heads up on what something could look like, we're doing this type of problem. So I'm going to reorder this to put the 2x first and then the 4y. Now I did this because I know that 2x and x squared have something in common, and 4y and 2xy have something in common. But these two don't have anything in common, and that's the issue. Okay, so I'm going to try to rearrange first just to see if I could come up with something. So let's go ahead and try to do the grouping. We'll see what happens. X squared and 2x both have x. And 4y and 2xy both have 2 y's. So I'm going to take out a positive 2y. And when I take 2y out of 4y, I end up with 2. And when I take 2y out of 2xy, right, that goes away, and we're just left with x. Do my insides match? Technically, no. However, the commutative property says that x plus 2 is the same thing as 2 plus x. So because they both happen to be positive, I can actually switch them, like flip the order, with no consequence, which means that they do match. They actually do. So one of my factors is x plus 2. And the other factor ends up being the outside, just like before, and we get x plus 2y. Now let me just show you some other things that might bother you a little bit. That way, when we get to class, they might not bother you so much. Now, the first thing you should always be doing, and I know I haven't been doing this, but you should, right, based on all of the videos, or the last video that you watched, is look at it, try to find a GCF that you can take out, if possible. 2x cubed plus 6x squared minus 2x all have x in them. It's very apparent just by looking at them immediately. So you can take an x out. So I'm going to do that. Let's take an x out. I can also divide all of them by 2. And that's probably obvious too, so you can take both out at the same time. We end up with x squared plus 3x minus 1, right? Don't forget that when you divide something by itself, you get 1. It does not disappear, you get 1. Now, in order to do my cross method, or even the first method, right, just finding factors of c that add to the middle term. We're finding factors of this that add to this. Well, let's list our factors of negative 1. What are factors of negative 1? The only thing that multiplies to negative 1 are 1 and negative 1. Well, 1 minus 1 is 0, which means that this is not factorable any further. You have actually factored it by taking out a GCF, but we're stuck. We can't go on. This is the answer. That's it. No moving on. It's not factorable on the inside. Okay, and that bothers some people, but it's okay. It can happen. It can happen. Now, again, in example 6, I would suggest always looking for a GCF if possible, right? Because you haven't seen an x to the 4th power. So you can kind of assume that there's going to be something that allows you to know how to do something like this. 5 and 45 both have 5, so I'm going to take that out. X to the 4th and x squared both have x squared, so I'm going to take that out as well. X squared out of x to the 4th is x squared. 45 x squared, and you take out 5x squared, and you get negative 9. Look, x squared and negative 9 are both perfect squares. This means we are not done with this problem yet. This is in fact factorable, and it happens to be a difference of 2 squares like you did in examples 1 and 2. So A, what squared makes x squared? X. What squared makes 9? 3. So that inside factors 2, x plus 3, x minus 3. But don't forget, we still have this. That doesn't disappear. It's still 5x squared. And that's our answer. That's as factored as it gets. So those are your weird cases, and we'll probably do more in class. Have a great day.